and we're going to put our address like so. So it's the current directory, and then we just put passwords after. In that, we can see that there's a file called accounts.txt. And going here, we can see that we got some usernames and passwords. So we can see there's admin pass. We can see that we have a password as Adrian and some password. So we managed to find usernames and passwords. Now we're still not sure what these usernames and passwords for, but we're sure that we were able to find very useful stuff. Another useful file is the config.inc. So let's see what's in that. And from here we can see that we have information that allows us to connect to the database, because these are saying db host, db user, db pass, and name. So we can see that the username is root and the password is blank. So we can go ahead and try to connect to the database based on these commands, and then we should be able to get access to that database. Also, using these passwords, we're still not sure what we can use them for, but we can add them to a list, try to log into the admin, or just store them in a list so that we can use it if we're going to do any brute force attack. So then again, this is another video that just shows how important and powerful information gathering can be. So far, we learned how to find any subdomains that exist within our target website and that have not been listed. In today's lecture, we're going to see how we can find files and directories that are stored on our target computer or our target website. Again, these could be useful because these files could contain passwords, they could contain config information, or they could contain information about the actual server, which will help us further exploit our target. Let me just first show you what I mean by files and directories, just to show you the structure of directories on a web server. So here I have my Metasploitable machine, and as we know, usually the web server stuff is stored in var www, and if I do an ls, you'll see, or I'll do an lsla just so that it's nicer, you'll see that we have a number of files and directories, and we can see that we have a directory there called Metilidae. Metilidae is a web application that is designed to be hacked. Just like Metasploitable, it is designed so that it has a number of exploits so that we can learn how to hack based on it. So we can see that that's installed in a directory called Metilidae. Now if I go here to my IP address, now this is the IP address of the Metasploitable machine. So if I do an ifconfig here, you'll see that it's 10.20.14.204. So I'm in there, and you can see that they have an easy access for me for Metilidae. If I click it, look at the URL here. So it's /Metilidae. That means I'm inside the Metilidae directory. So every time you see a /, that usually means you're inside a directory. So let's go back here, do an ls, and if I do cd Metilidae, I'm going to do an ls, and you'll see that I have a large number of files here. So let's say, for example, I wanted to open one of these files, and we have index.php. If I do index.php, then this is our current file. It's called index.php. So what we learn from this is Metilidae is just a directory inside my web root. So at the moment in the Metasploitable device, I'm in, let me just write it here for you. So I'm in var www Metilidae, and then the file that I'm accessing is index.php. Okay, so I hope this is clear now. So I'm in this directory, and I'm accessing a file called index.php. So if I just do a pwd here, you'll see that I'm in var www Metilidae. The IP address kind of hides where your www root is, so it hides the var www, and then everything after that will be displayed here after the IP address. So what we're looking to find today is all the directories and the files that we cannot see. So throughout these links, we will be able to access different types and different pages. This is the same with any other website, but there is always files and directories hidden that you just never see. So we'll see how we can get URLs for these files and access them and read the information in it. To do that, we're going to use a tool called dirb. And to see how to use that tool, we're going to do man dirb to see all the options associated with that tool. So you can see that to use the tool, you just type in dirb, the URL of your target, and then you put a word list. So the way this works is it works based on a brute force attack, and it just uses a word list of names and it sends requests with these names, and anytime it actually finds something, it tells us that, oh, I found a file with this name. So it will only be able to find names and directories based on the word list that you provide. Now you can create a word list using Crunch, or you can use word lists that come in within dirb. The options here allow you to configure how the tool is going to work. So you can change things around the way you want it. For example, you can disable the recursiveness of the tool, so it just runs on one directory instead of trying a number of directories. You can get it to ask you if you want it to access a directory or not, instead of it automatically accessing directories and trying to find files within these directories, because this could be exhaustive if your target is a big website. There might be a lot of directories, and then the tool will be trying to access all of them and find files within all of them. So you can see how big the tree could go. You can also set it to use a username and a password if the target website uses some sort of authentication. You can use V for verbose output. And you can also use O to output the results to a file. So let me show you a very simple example of it. I'm just going to run dirb on our target, which is 10, 20, 14, 204. And that should be HTTP. Because remember, we're targeting a website, not an IP address. Then I'm going to put the directory that I want to find files and directories within. I don't want it to be accessing anything within other, because we can see here there's a number of scripts installed on this web server. So we have this script, and we also have phpMyAdmin, and we have TikiWiki. So we don't want it to be accessing all of them. We only want it to be working on Matilda on this example. So that's why I'm only using this URL, and then it's going to start finding URLs and files within this particular web application. So I'm going to hit enter, and we're going to let it to work. So this is going to use a word list file, and it's using a default small word list file that is stored in here. So it's in user shared dirb word lists common.txt. You can have a look on this directory and see if there is any other word lists that you'd like to use, and you can use them only by placing the full path to the word list after the command. So instead of the way I wrote the command, you'd write it like this, and then you'd state where your word list is. For example, let's say if it's in root, you state it as root word list .txt or whatever. But at the moment, it's using the default one, which is stored in this directory in user shared dirb word lists, and it's using the one that's called common.txt. In this lecture, we're going to have a look on file upload vulnerabilities. These are the simplest type of vulnerabilities because they allow us to upload any type of file. So, for example, if the target computer can understand PHP, then we can upload any PHP file or a PHP shell and get full control over the target computer. Now, if the target computer or the target server understands Python or any other language, then you can just upload Python code, Python shell, or Ruby shell. You can create these shells using vil evasion or Metasploit, or you can use your own PHP or Python shell. What we're going to do today, we're going to have a look on a tool called Weavly that generates PHP shells and allow us to gain access and do a number of cool things on the target computer. So first of all, I have my DVWA here. And usually when you're trying to pen test a website, what I recommend is before trying to use any tools or anything, after you do your information gathering, is you just go in and try to browse the website, see what you can see, just get a feel of the website, see what's installed on it and all that, and try to exploit any features you see. So for example, let's say you went on everything and then you reached the upload. We can see that this website allows us to upload a file. Now this sometimes in your penetration testing tasks, it could be a website that's allowing you to upload a profile picture, if it's a classified website, maybe it's allowing you to upload pictures of cars or whatever you're trying to add in the website. So as you can see here, the website expects you to choose an image and upload an image. So let's see if we can upload an image first. So I'm going to go on my downloads and I have a picture here in the resources, just a picture of a car. I'm going to upload it and see if it gets uploaded. And we can see that the upload was successful and it's stored in this particular location. So it's ... which means 2 directories back and then this file name. So let's see if the picture has actually been uploaded. So I'm taking away 2 directories. I'm taking away the vulnerabilities and upload. I'm only using that. And then we're going to get this location on the server just to see if the picture was uploaded properly. And as we can see, the picture has been uploaded, so that's all good. Now the next thing we want to do, let's try and upload a PHP file. And to do that, we're going to use a tool called Weavly, as I said, to create a payload or a shell, if you want to call it. And it's obviously going to be a PHP shell. You can use Metasploit, as I said, to create a PHP payload. But we're going to be just having a look on a different tool that's designed for web application penetration testing. So the tool is very easy. We're going to put the tool name, which is Weavly, and then we're going to put generate, because we want to generate a payload or a shell file. Then we will put a password for that file so that only us can access it and control the website when we upload it to the website. So my password is going to be 123456. And then I'm going to say where I want to store it, and I want to store it in root, and I'm going to call it shell.php. So very simple. Weavly is the name of the program. Generate is to generate a shell. The password that the shell is going to authenticate us with, and it's going to be stored in root shell.php. I'm going to hit enter, and it's created. Now if I'm already in my root, so if I just do ls, I should see it. And we can see it right here. So the next thing is we're just going to go back to our website and try to upload that shell. And I'm going to look for shell, and here it is. I'm going to hit on upload. And as you can see now, it's telling me the file has been uploaded successfully, and it's in the same place that the picture was. So all we need to do now is we're going to use the same link, and we're going to use Weavly again to interact with that shell that we uploaded. Now let's first of all see if the shell exists and it's been uploaded properly. So I'm just going to browse it through my browser. Shell.php, and you can see that you get a blank page, so we're not getting 404 file not found, which means that the file has been uploaded and it's there. So we're going to try to interact with it from Weavly. To connect to it, we're going to type in Weavly, and then we're going to put the URL where the shell is. So this is where our shell has been uploaded, and then we're going to put the password. So my password was 123456. Very simple. Weavly, the URL where the file is, and 123456. This is very simple, similar to when you use your multi-handler waiting for connections or connecting to your backdoor. So we're literally just going to connect to the backdoor that we uploaded. And as you can see, now we're in the file system. So from Weavly, from this place, you can actually just type in any Linux command, and it'll be executed on the target computer, and you'll see the result here. So if I do a pwd, you'll see that I'm in var www hackable uploads, and if I do an ID, I'll see my user at the moment, which is www data, and if you do a uname A just to confirm that this is the Metasploitable machine. You'll see that this is the Linux Metasploitable machine. Now we can do anything we want. We can list the files, we can navigate, you can do any Linux command that you want to do. Now we have changed, our place has been changed. Weebly also offers much more features than just this. So it actually allows you to do a number of cool things. If you type in help, you'll see all the cool stuff that you can do with Weebly. So you can try to escalate your privileges, execute SQL queries, and a lot of cool stuff that is just designed for web application penetration testing. For now, I'm going to leave it at this. And this just shows you how to use file upload vulnerabilities. Code execution vulnerabilities. These type of vulnerabilities allow us to execute operating system code on the target server. So if the target server uses Windows, we'll be able to execute Windows commands. If it uses Linux, then we'll be able to use Linux commands. Clearly, this is a really critical problem that would allow us to do anything we want with the target, really. We can upload a PHP shell using a wget command, or upload a payload, a virus, anything we want using the wget Linux command. You just need to make sure that you're uploading it to a file or to a directory which you're allowed to write stuff to. Another way of exploiting this vulnerability is to just run OS commands and get a reverse shell based on these commands. So because we can run operating system commands, we can use the programming languages supported by that operating system to try and get a reverse connection on our computer. So first of all, let's just assume that we're browsing here and we're going around, and then we got to a tab in the website where it allows you to, for example, do a ping. Now, what you should do is you should always try to experiment with any input box you see. Try to see what that input box does and what can you inject into it. What can you do to get stuff running? So, for example, this input box is telling you it's going to do a ping. And if you put an IP, for example, I'm going to put 10.20.14.203, which is my own IP, just to use it as a normal person. And I'm going to do a submit. And it's going to go ahead and ping it for me and give me the ping results. So what looks like here, it's actually executing the ping command in Linux systems. Now, let's see if we can exploit that. If it's actually executing the ping command. So what it's doing is it's going and it's doing, so we're sending 10.20.14.203 as the ping, and then it's going to the web server, and the web server is doing ping 10.20.14.203. So let's see if we can exploit this. How would we exploit it if it's taking what we're inputting right here, and then it's doing ping that? Now, in Linux and Unix-based commands, you can use this sign to execute multiple commands on one line. So if you do this, if, for example, in your own terminal, so I'm just going to go to my terminal here, and I'm just going to do ls, which is the list command, and then pwd is what shows your working directory. So if I do an ls followed by this sign and then do pwd, it'll execute both commands. So it'll do this, and then it'll show where the working directory is. So we can do the same thing with this and see if it works for us. So we're going to put an IP, a right IP, and then I'm just going to do pwd and see if it'll execute the pwd for me. If it does, then this is a code execution vulnerability, and I can execute anything I want on the server. So let's see what's going to happen. I pasted this, and I'm going to hit submit. And as we can see, we got the ping results, but at the end, we got our current working directory. So it's var www dvwa vulnerabilities and exec. So it executed the pwd that I inserted. And that means I can insert any commands I want in there and they'll be executed. So I've inserted a resources file that you can use to get reverse connection from the target computer. Now there's a number of ways, a number of commands that would give you a reverse connection. All of these commands depend on the programming language. So for example, we have commands in PHP, we have commands in Ruby, you have Perl commands, and we have the one for Bash. Bash is the Linux shell command language. So all Unix operating systems will be able to execute Bash commands. So that's a very good way of doing it. So most Unix system, this command should work on most Unix-based systems. So this would be a really good way of doing it. Again, most of them would have Python, so Python would be a good way. Netcat, most of them do have Netcat as well, so Netcat is a good way of doing that. And we're actually going to use Netcat in this video. So what I'm going to do is first I'm going to listen for connections, just like we used to do with Metasploit when we used to do multi-handler. You can actually use a multi-handler for this and listen for connections, but I'm just going to keep it simpler and show you a new way. And I'm going to use Netcat. So Netcat. Netcat is just a tool that allows you to listen and connect computers together. So I'm going to listen on port 8080. So Netcat is the program. VV is just to see verbose output. So we can see a lot of output. Anything goes wrong, we can see it. And we're telling it to listen using the L option on port 8080. So I'm going to hit enter. And that's saying it's just listening on port 8080. That's all it's going to do. The next command we're going to do is we're going to try to connect from the web server back to my computer using Netcat as well. So we're assuming the web server has Netcat. We're going to try it and see if that works. So the command is very simple. It's Netcat, and we're telling it to use the bin bash. And we're giving it the IP of my device, my attacker device, which is 10.20.14. And then the port, which is 8080, which is we're listening on right here. So I'm going to copy that. And I'm just going to execute it the same way we used to execute the pwd command. So the last thing we did was 10.20.14.203. And then we did pwd. So what I'm going to do now, I'm going to remove the pwd and paste the code that we just created, which will try to connect from the web server back to the Kali machine to the attacker machine. And I'm going to come here. And as you can see, we got a connection back to us from 10.20.14.204. So that's the target computer. And if we do a pwd, you'll see that we have a reverse shell. If we do an ls, if we do an id, you'll see that we're www data. And if we do a uname a, just to confirm that I'm in the Metasploitable, and you can see that I'm in the Metasploitable, and I'm able to run any command that I want on the target computer. So basically, I have full access to the target computer. Local file inclusion vulnerabilities. These exploits or vulnerabilities allow you to read any file that is within the same server. So even if the file exists outside the var www, you'll be able to read it and read info with it. Now, why this vulnerability is critical, because you can read any files. So if the users are storing some sort of important files or password files, then you'll be able to read them. And then from there, you can further exploit your target. Also, if there is a number of websites on the same server, and you manage to find this on a website that you're not targeting, then you might be able to access files related to the website that you're targeting and then further exploit your website from there. So let's have a look on this. And the way we're going to be exploiting this vulnerability is through the URL. So usually in our code execution example, we were writing the code in here. Now, sometimes you might find the code vulnerability in the URL. So it will be something like cmd, and then you put the command, or for example, in this case, it would be IP equals to the IP, for example, 10.20.14.203, and then you put the sign, and then you put your pwd after it, for example. So, because our example was just in the text box. Same is going to happen here in our file inclusion vulnerability. So we can see that when you're in here in this URL, it's saying that this file is going to take a page and it's loading something called include.php. So it looks like it's actually loading another page, like this current page is loading another page called include.php. So again, you'd be browsing the web server and trying to get a feel of it, and you see something like this, or you see something called IP equals the IP, and then you know that there's a ping, for example, for the previous video. So for this, that we know that our target is trying to open a file, and the file is called include.php. Let's see if there is actually a file called include.php. So I'm just going to remove everything here and try to access include.php directly. And as we can see, we actually do have a file called include.php. It's not running properly, but it exists and it's in the same working directory. So let's try and see if we can read a file that is stored in the computer. And we're going to use a file called etc password. So that's the file which contains all the users and their paths on the current web server. So let's have a look on this. So etc, this file contains all the users for the current operating system. So if I just go on my Kali right here, and if I run it here, if I just do cat etc password, you'll see all the users that I have on the current computer and their default path on the current operating system. So we're going to try to read this file. And to do that, let's go back and see our current location. So our current location is in the FI file, in the FI directory. So we need to go back 1, 2, 3, 4, 5 times, and then go to etc password. So going back would be done using the ... And let's try and do that. So at the moment, we're accessing this current file. And just to make it easier for you, actually, let's just put the full path right here. So in the page, it's trying to access this page. So what we actually want a place called etc password. So we need to go back 5 times for these directories. So this one is going to be, let's start them from here. So we're going back, 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 and back. And then we're going to go to etc password. And as you can see, now we have the output of the etc password file. We can copy that and store it here. And then you'll be able to read it and just get more information about the websites that you're targeting right now. Again, you can use this to try to access different files, sensitive files, or files of other websites on the same server. Remote file inclusion is a special case of file inclusion vulnerabilities. We've seen in the previous video how we were able to include any file in the server and have access to it through local file inclusion vulnerabilities. In today's video, if the server is configured to allow a certain function called allow URL and allow URL fopen, then we will be able to include any file from any computer into the target website. So we'll literally be able to inject any PHP file into the target computer. What this would lead to is basically we can run payloads, we can run reverse shells, and we can run even system commands and get access to the target or full control to the target server. So first of all, let's just go here and we'll be using the same file inclusion vulnerability that we were using in the previous video. So it's in the page parameter right here. The only difference is you need to enable the function that converts the local file inclusion to a remote file inclusion. So hence the name local allows you to access local files. Remote will allow you to access and inject remote files. So To enable that, I'm going to go to my Metasploitable machine. I'm just going to show you how to enable it so you can test this vulnerability yourself. So we're coming here to our Metasploitable, and I'm going to go into the PHP settings. So the PHP settings are stored in a file. And to access that, we're going to use Nano, which is a text editor. And then I'm going to put the file location, which is in etc php5 cgi and php.ini. So that's the location where the PHP configuration is stored. I'm going to open it using a file editor called Nano. And I'm just going to exit this. I'm going to open it as sudo as the root. Actually, in Kali, we never needed to use sudo because we log in as root. But with Metasploitable, you need to use sudo when you want to do root actions. So you say sudo, and then you put the command that you want to run. Okay, so these are the configurations for the PHP that's installed on the web server on the target. And we're looking for a function called allow URL fopen. So I'm going to type in Control and W at the same time, and that'll allow me to search. And I'm going to search for allow URL. And we can see here that I have allow URL fopen is on, and allow URL include is on as well. So these two functions, if they're enabled, then the local file inclusion vulnerability that we have can be used as a remote file inclusion. So to exit this, Control and X, and it's going to ask you if you want to save, just type in Y and enter. For me, I didn't change anything, so I didn't need to do that. Once you do that, you need to restart your web server. So you're going to do etc init.d apache2 restart. And you'll need to do this as sudo actually. And this is done now, so everything should be ready for you. Just like we did before, in the last video, we put 5 times back and then we put etc password to access the password file. What we're going to do today is we're going to try to access a file located on a different server. So if you're doing this pen test on an actual web server, then you need to store the file that you want to access needs to be stored on a place with a real IP address or with a domain name. I'm doing this on my local server, so I'm going to store this on the web server on the Kali machine on the 10.20.14.203. This is 10.20.14.204, and I'm going to store my file on 10.20.14.203. So that file, as I said, can be anything. It could be a web shell, it could be a payload. Well, what I'm going to do is I'm going to create a very simple PHP file. So this is just the PHP start and end of the file. And what I'm going to put in the file, I'm going to use a function called passthrough. And in that function, basically what this function does, it executes operating system commands. So it executes Windows, Linux, or depending on the web server, it's going to execute commands related to that. So you put the command here between the two quotation marks, and I'm going to use the same command we used with the code execution vulnerability, which was the netcat command, which allowed us to get a connection, a reverse connection from our target. So I'm going to paste that here. So let's just first have a look on this. So PHP and the end, these are just the start and the end of the file, of the PHP file. Passthrough is a function that I'm going to use which executes any command that's inserted between the quotations. And I'm using the same command that we used in the command execution vulnerability, which will just do a reverse connection to my computer. So this is all good. Now the next step is the most important step, and it's storing this file. So as I said, if your target was a remote web server, then you should be storing this file in a place with a real IP where you can access it from the remote web server. Now I'm going to be trying to access this from my Metasploitable machine, which is able to access files stored on the Kali machine because they're both on the same network. And I'm going to be calling this, I'm going to be storing it in my var www.html. So it's being stored on the Kali, not on the Metasploitable. And I'm going to call it reverse, and I'm gonna save it as txt, not PHP. And I'm doing this, if I start it as a PHP, it's going to be executed on the Kali machine. So it's going to create a reverse connection from the Kali machine. And I don't want that. I don't want to hack the Kali machine. I actually already have access to the Kali machine. The one that I want to hack is the Metasploitable machine. And that one is stored remotely. So in order to be able to include the PHP code and execute it on the remote machine, we're going to use it as txt and get it executed on the Metasploitable machine instead of executing it on my Kali. So I'm starting it as a txt, and I'm going to save it. And now let's just see here. So if I go to my local host, and if I say reverse.txt, we'll see our file right here. So again, this is on my local host, which is not the Metasploitable machine. It's 10.20.14.203, and the Metasploitable is on 204. So how are we going to run this? First, let me just listen for connections like we did before. So it's just going to be netcat vvlp 8080. And then right here, instead of including a file on the same server, I'm going to include a remote file, and the command is going to be http. So it's just going to be the link to this file. So we can access the file here as txt. I'm going to copy it and paste it here. And also in some cases, you might need to add a question mark to the end to get this file to be executed as PHP. So I'm just going to go over this again for one more time. Including a remote file, which is on a remote server. Make sure the remote server is accessible by your target. And also make sure you store it as txt, because if you keep it as PHP, this file, the reverse file, will be executed on the remote server. So it will be executed on the 203 instead of being executed on the 204. And I'm keeping it as txt. This way it's going to be executed on the 204, and it's going to give me a remote connection to this computer, to the Metasploitable computer. So if I come back here, as you can see, we have a remote connection. If we do a uname A, you'll see that this is the Metasploitable machine, not the Kali machine. So we basically have full access to the Metasploitable machine through a remote file inclusion vulnerability. Now, if we do an ls, we can do a pwd to see where we are, and we can literally run any Linux command we want now on the machine and do anything we want. Basically, we have full access to that machine. Let's talk about how we can prevent these vulnerabilities now. The first thing is, a lot of these vulnerabilities exist because of the functionality they provide. For example, the file upload problem we had, it allows the user to upload any file extension, any file type. This shouldn't happen. There shouldn't be a way for users to upload any files they want. Maybe if you want them to upload a picture, then make sure they're uploading a picture. Check the file types. If you're expecting them to upload a song, an MP3 file, make sure it's a media file. It's not a PHP or an executable code. Usually, you should never allow users to upload any executables. Filters can be used to check the extension and make sure that the file is being uploaded that is a JPEG or whatever, but that's not a good way. The best way is to check the file type and make sure the file type is a picture or is a media file instead of checking the extension, because that can be bypassed as well. The second type of vulnerabilities that we looked at was the code execution vulnerabilities. In these exploits, we were able to run any code we wanted on the target computer. Again, this functionality should be avoided. You should avoid allowing users to run any sort of code on your server. Try to avoid all these functions such as the eval, pass-through, and all these functions that allow a user to run operating system code on the server. If you absolutely had to use something like it, then make sure you analyze the input before you execute it. For example, in the example we seen, where the code was doing a ping, and it'll ping anything we put in the text box. So I'm putting here a $text box just to show that this is the input that we put in the text box. This is what the program actually looks like. If it looks complicated, forget about it. We're just talking about the concept here. So we're going to be talking about this here. So say, for example, what we did is we put a normal IP, and then we put the semicolon, and then we put a command that we wanted to do. So we did, for example, lsla. The problem with this is the web application used to take this the way it is, copy it, and run it in here, which will, when you execute this command, it will do the ping first, and then it'll do the lsla, which is the command that we wanted. What you need to do is, for example, if you had to do it, what I advise is you just don't use these functions. If you had to use a function like this, then what you should do is check that the input is what you're expecting. For example, you're expecting an IP address and nothing else. So you can use regex to make sure. Now, I'm not going to talk about regex or what regex is. Regex is basically a rule that will make sure that the input looks on the following format. So it takes a digit, dot, digit, dot, digit, dot, digit, which if I put anything else, then the web application should refuse it. You can also make sure that there is no semicolons and that there is no spaces. So everything comes in as one thing and then it gets executed. Again, this is a way of making it more secure, but the best thing is just to avoid these functions. The third type of vulnerability that we looked at was the file inclusion, and we looked at two types. The local file inclusion, which allowed us to include any file on the system and then read files, which will cause a file disclosure vulnerability, and then you'd be able to read any file on the server. And then we looked at the remote file inclusion, which is very dangerous, which allowed us to include any file from any web server. So we were able to include PHP shells and then get connection from the target computer. To prevent these, first of all, make sure you prevent the remote file inclusion. So just in case anything goes wrong, people can't include files from outside your server. And you can do that the same way we enabled it using the PHP INI, by disabling the allow URL fopen and allow URL include. And if we go here to our Metasploitable, I'll just show you very quick. So if we do sudo nano, which is the text editor, etc php cgi php.ini, the same file that we used. This is the file for the PHP settings. If you open that file, and now I'm going to do Control W and look for allow URL. And you want to make sure that the allow URL of open is set to off, and allow URL include is set to off as well. Control X, Y, and enter, and that'll save it for you. The other way to prevent these exploits is to use static file inclusion. So instead of using dynamic file inclusion, which we've seen, you can hard code the files that you want to include in the code and not get them using get or post. For example, what's happening in the examples we see in the vulnerable examples is we have a page called page or index.php. And then this index.php takes a parameter called page, and then it takes another page, for example, news.php. And it includes this news.php in the code. So what's the code look like? In the PHP code, you'll see something like include So what this will do basically, and that looks like this, I believe. What this do, it includes whatever comes after the page parameter. So the code will dynamically takes whatever that comes in after the page parameter and includes it in the current page. So this will be in the index.php page. Okay, this is very bad because even if it's not get, sometimes people use post, and in post you won't see this, so it will be posted. But you can use a proxy such as burp proxy, and this would look like that. And then you can modify it and get it to include anything you want, and then it's displayed on the page. What we really want to do is we want the user not to be able to manipulate with what's going to be included. So if you wanted to include a page called news.php, just include it inside this without giving the user the ability to change it. I know you're going to program your code to just have it looking like this, but the users, we've seen how users can play with this and just get it to include anything they want. So the best way to do it is just to get it to include page.php. So your code is not using any variables. It's hard coded. It might make your code longer, but it's much more secure. In this lecture and the next few lectures, we're going to be talking about a popular type of vulnerabilities called SQL injections. Before we start talking about how this occurs and how to exploit it, let's first learn what SQL is. Now, if you're getting a pen test on a certain website, chances are this website is a little bit bigger than smaller websites, so it's probably using a database. Most websites, other than very simple websites, use databases. And the databases are used to store data. So they store usernames, passwords, news articles, blog posts, pictures, anything that happens on the website literally is stored on a database. And the web application queries the database and then displays the data to you or to the users on screen. When the users do something, it will either update, delete, or modify the data that exists in the database. This interaction between the web application and the database happens using a language called SQL. So let me show you what I mean by a database. This is just an example. I'm not hacking anything. I'm literally just going to log in to the database that is installed on our Metasploitable machine, and then we're just going to see what's being stored on it. So I'm not doing any hacking. There's nothing here, nothing fancy. Just logging into my SQL. And then I'm putting the username is root, and the Metasploitable doesn't use a password for the root, which is really bad, but obviously it's a vulnerable system. So I'm just going to log in, and I'm not hacking anything. I'm not doing any SQL injections. This is just the terminal for MySQL, which the web application would use to interact with the database. So I'm just trying to show you what I mean by databases and what's saved in there. So the first thing I'm going to do is I'm just going to type in show databases. And that will show us the databases that exist on our target server. And we can see that we have the information schema. This is a default database that holds default information about all the other databases. So this one gets installed by default when you install MySQL. The rest have been installed for each web application. So we can see we have one for TikiWiki, we have one for OWASP 10, and that's for this one, Matilda. We also have one called MySQL, we have one called Metasploit, and one for DVWA, which is the one that we've been using, the web application. So you can see for each web application, we actually have a database, and this database holds the information that is used by that web application. Let me show you what's in there. So I'm going to use the OWASP 10 database. So this is the one that is, again, this is the one for Matilda for this web application. And we can see the tables. So each database has a tables, and in the tables there's information. So I'm going to say show tables to see the tables that we have. And you can see we have a table for accounts. So you can assume that this table has information about the usernames, passwords, and information about the users. We have a table for blogs. So probably has the blog inputs, the posts, and the comments in there. You can see captured data, credit cards. So there's a table that contains credit cards. Now this is huge for shopping websites. They actually would have credit cards table, and the information for the credit cards would be stored there. Basically, the database will store everything, all the data that is used on the website, because they don't get stored on files. It's not efficient. So let's have a look on the accounts. And if I just say select, so this is exactly how the web application would be retrieving information from the database. It will be selecting stuff, updating, or deleting. So I'm doing a select statement here. Again, this is not hacking. I'm not doing anything, just selecting stuff. and I'm going to select star, which means everything, from accounts. Apostrophe, and as we can see, we have the account ID, the username, the password, and then the signature for the person, and if that person is an admin. Now, these columns depend on the table, so it's actually the person who designs the database, designs the tables, the columns as well, and then the data gets inserted by the web application. So we can see that we have a user called admin, and their password is admin pass. We can see we have a user called Adrian, and their password is some password. So this is just to show you what databases look like and just to get a feel on it, because in the future videos, we're going to try to exploit these databases and have access similar to this. So this, I just logged in with a username and a password now. Usually you wouldn't have access like this. Only the web admin would have that access. In the future videos, we're going to try to run some attacks in order to gain access similar to this, so that we'll have full control over the database, so that we can read stuff and see if we can write or modify things. So I just want to highlight why SQL injections are so important and so dangerous. The reason behind that is they are found, you can find them everywhere. A lot of places, a lot of big websites have these kind of exploits. And like things like Yahoo, Google had them. They're very hard to protect against, and it's very easy to make a mistake to make these exploits available for exploitation. The other reason that they're very dangerous is that they give you access to the database. In many scenarios, if you find an SQL injection, you really don't need to upload a PHP shell or get a reverse connection. There is really no point of uploading stuff and then increasing the danger of being caught. Because if you have access to the database, as we see in here, you pretty much have everything you need. You have usernames, passwords. You can log in with normal username and a password as a normal user. Or you can, if you're looking for sensitive data, we can see that we've had access to credit cards. You pretty much can do anything you want. So there's really no point of trying to further exploit the system. If you found an SQL injection, bingo, like that's all you need really. In many scenarios, we actually use a PHP shell to gain access to the database and see if we can read it. Like say, for example, if you manage to upload a PHP shell on this server, the Metasploitable, but then you couldn't access the database. There isn't much that you can see. You can't see credit cards. You can't see username and passwords. You really can't. Yeah, you have control over the server, but you can't read stuff. So sometimes when you upload a PHP shell, the next step is I need to gain access to the database. Another thing is that they can be used to do many things. So if you manage to find an SQL injection in a website that is not your target, so it's not the one that you're targeting, but it's in the same server, then you can use it to read files outside the www root. So similar to file inclusion vulnerabilities. You can use the admin, the username and password for the admin, and see if you can upload stuff. Usually the admin can upload a lot of things instead of just images, and then you can upload a PHP shell or a backdoor from there, and then from there navigate to your target computer, or to the target website, sorry. Or you can actually, in some cases, you can use it to upload a PHP shell. You can use an SQL injection to upload a PHP shell. So basically, SQL injections can be used as file inclusion vulnerabilities. They can be used as file upload vulnerabilities. And also, they'll give you access to the whole database. That's why they are very, very dangerous and very useful if you manage to find one. Okay, so now we know that we can put any code we want in here, and it's going to be executed on the system. So let's have another look now at the statement. So the statement says select star from accounts where username is equal to the username that we put here and password is equal to the password that we put there. Let's see if we can use that to log in without using a password, without even knowing the password. And I'm going to be doing that with the admin. So with the admin, the username is going to be admin. And I don't know what the password is for the admin. So what I'm going to do, I'm just going to put anything. So nothing really, any random password. And in the code, what I should run here, we were doing and 1 is equal to 1 and or stuff. So what I'm going to do is I'm going to do or instead of and I'm going to say 1 is equal to 1. So what our code is going to be, once I run this, once I inject this, this is going to go in here like we were doing before. So our code is going to look like this. So it's going to be select star from accounts where username is equal to admin and password is equal to AAA. Now this is wrong. Or 1 is equal to 1, which is right. So anytime you have an or, if the or condition is right, everything is right. That's the way or statement works. So select star from accounts where username is equal to admin. Okay, username is equal to admin. And password is equal to AAA. That's wrong. Or 1 is equal to 1. Okay, I'll accept that. And then it's actually going to execute it and let us log into the admin without even knowing the password for the admin. So let's try to inject this now. And as you can see, I was able to log in as admin, and monkey is the signature for the admin. Now, bypassing logins can be done in so many ways, depending on the code that's written on the page and depending on the way you want to do it and how you're imagining the code. In a lot of the cases, when you put the single quote here, you won't see this message. Sometimes you do see it, which makes your job so much easier. If you don't, then you kind of need to guess what it looks like. So I'm going to show you another example of bypassing. Instead of injecting the code like this, the admin parameter is actually injectable as well. As you've seen when I put the single quote, the admin parameter is injectable exactly the same way as the password. So we can inject code in the username as well. And what I'm going to do now, so let's have a look on this. And I'm just going to reset it to the way it would usually look like. So you'd have, and the username and the password are the fields that whatever you put in here are going to be substituted in the username and the password. So let's try to inject something in the username. And what I'm going to say is I'm going to say username is equal to admin. And then I'm going to close the quote myself. And then I'm going to add a comment. So my statement, when I run this statement, it's going to look like this. And I'm actually just going to copy it here. And when I put this code in here in my name, it's going to inject that in there. So this is what the code is going to look like. It's going to select star from accounts where username is equal to admin. I close the quote myself here using this right there. And then I'm adding a comment. So basically all of this is not even going to be executed. So the code is going to be this. It's going to be select star from accounts where username is equal to admin. And it's going to let me log in without even entering anything in the password. So let's do this. I'm going to put my username as admin. And I close the quote and add a comment. And then you can put any password you want really. I'm just going to put number 1. And then I'm going to log in. And as you can see, I managed to log in as admin. So again, this is black box testing, so you don't really see the code. In many cases, you want to be playing around with it and see how it works with you. But the main thing is you want to test if the SQL injection exists, and you'd use that using the method we showed you in the previous video. So try a single quote, try the AND statement, try a true AND statement, so 1 is equal to 1, and then a false AND statement, so 1 is equal to 0 or 2 is equal to 0. And if they work as expected, then your target has an SQL injection and you can start playing around with it. Now, to try and discover SQL injections, you need to browse through your target and try to break each page. So whenever you see a text box or a parameter on this form, for example, page.php, then something is equal to something, try to inject stuff here. So try to use a single quote, try to use an AND or the order by statement to break the page and make it look different. So I'm going to show you here an example. And I'm going to go into the login page first, right here. And it's asking me to log in. Now I've actually registered with my own name, so you can just go in here and register. I have a username called Zaid and a password with 123456. So first I'm going to log in just to show you. So my username is Zaid and my password is 123456. And now I'm logged in as Zaid, and my signature was AA. It's just nothing really, just like as a test. So I'm gonna log out, and we're back at the login page. Right here we have the page, so you can try to inject in that, but we'll get into that later. So at the moment we're having an example of injecting into text boxes. So you can try to inject into the name and into the password. So I'm gonna put my name as Zaid, and I'm gonna put a single quote. So I'm putting this sign into my password. So let's see if we can break it. And as you can see now, there is an error being displayed to us, and it doesn't look like a normal error. It looks like it's a database error. And usually you would be very lucky if you get an error like this. Now, usually the error won't be as informative as this. Sometimes you'll just see that the page is not acting as you expected. Sometimes it'll just be a page that does not look as it should. For example, if it's a news page, maybe it'll have the article missing, or if it's a blog, it'll have one of the posts missing, or different kind of posts. So you need to keep an eye on what's changing. In this example, we are actually getting a really nice error. It's telling us which file it has, and it's telling us that there's an error in the statement, and the error near the quotation mark that we added. And it also tells us the statement that's being executed. This is really good for learning, because now we can see what's the statement that the system is trying to run. And the system is trying to do a select star, so it's trying to select everything from accounts, where the username is equal to Zaid, and the password is equal to a single quote. And note that the system, the web application, is already adding quotes around the name. So when I said Zaid, it added Zaid between two quotes, and it added the single quote that I added between another two quotes. So that's why we had 3 quotes right here. So from this it's like 70% that the target website has an SQL injection. We're still not sure if it can execute what we want it to do. So can I actually inject code and get it to be executed? Let's see if we can do that. So the username is going to be Zaid again. And what I'm going to do with the password, I'm going to put my password. So I'm going to put 1, 2, 3, 4, 5, 6. And then I'm closing it. So I'll tell you why I'm closing it, because the current statement in the system is it's select star from to Zaid, and is equal to, and it's going to open a single quote by itself. So let's call this as password. So we're treating this as a variable, and it takes in whatever I put in here, whatever I'm going to put in this box, and it's going to insert it instead of the S password, which is a variable. So I'm giving you an idea. So you need to be able to imagine this happening. So it's taking whatever I put in there, and it's going to put it between 2 single quotes, and it's going to be inserted in there and executed on the system. So what I'm doing is I'm going to put 1, 2, 3, 4, 5, 6, and I'm going to add the quote myself. So what I'm going to do right now, the code is going to be like this. So it's going to select this, and password is equal to that. And I have 2 quotes right now. Okay. And then what I'm going to do is I'm going to say, and 1 is equal to 1. So 1 is equal to 1. And I'm just trying to see if it's going to execute what I want it to do. So my statement right now is it's going to be select star from accounts, where username is equal to Zaid and password is equal to 1, 2, 3, 4, 5, 6. And note, I'm going to be inserting this myself. And 1 is equal to 1. One problem that the system is going to complain about is that we have an extra quote here, because I'm going to be inserting this myself in the text box. So it's going to be complaining about this. It's going to say this is an open quote and it's never has been closed. So what I'm going to do is I'm going to add a comment. And when you add a comment, basically everything that comes in after the comment will not be executed. I'm going to use the hash as the comment. So anything that comes in after the hash, the system is going to ignore. So what I'm going to inject now is going to be this, and 1 is equal to 1, and this. So as I said, usually what you have here you have /$password, or depending on what the programmer called it, but we're just imagining this. And I'm going to be inserting this inside. So when you do that and you insert it inside, this is what the code is going to look like. So it's going to look like the right username, the right password, and 1 is equal to 1, which is true. And then it's going to ignore this quote right here. So if we paste this, we should be able to log in. It should allow me to log in. And perfect, we were able to log in, and username is Zaid. So far we haven't done anything, but this kind of shows us that, is it running our code? Let's try a different thing now. Let's try to add a false statement. So what we did 1 equal 1, and that was correct, and it executed what we wanted. Let's try 1 equals 2, and this is false. So I have the right password, and I have the right username, but I added and 1 is equal to 2. And this should be wrong because it's false. 1 is not equal to 2, and I'm using an and, so everything has to be true. So it should give me an error, even though I'm going to put the right username, and I'm going to put the right password. So I'm putting 1, 2, 3, 4, 5, 6, and 1 is equal to 2. So it's going to be like, oh, this is wrong. And as you can see, it's giving me an authentication error, bad username or password, even though I'm given the right password and the right username. So this confirms that this website is actually injecting anything we want in the password. So we can use the password field to inject SQL code. And it's always going to be on this form. So we're going to put a password, and you're going to put your code here. So I'm just going to put it in capital code here, because we're going to put any password, close the quote, and then put the code that we want to execute on the system right here, and it's going to be executed on the target system. Okay, now I'd like to show you an SQL injection in a different file, in a different page, and I'll show you a few different things that you can do to exploit that vulnerability. So the first thing, I'm going to go to the login page, which is in here. User info. So the first time we went to the login page, from there, this time we went to the user info page. So this page will show you the information about the user, provided you give the username and password. So I'm going to do Zaid, and I'm going to put my password 1, 2, 3, 4, 5, 6, and it'll show my details, username and password, and my signature is AAA. So the statement that's being executed here is similar to what was being executed when you log in. So it's selecting star from accounts, where username is what you put in the user field, and password is what you put in the password field. So what we're going to do now is we're going to see a different way of exploiting this kind of vulnerability. In the previous video, we were doing it using a post text box. So whatever you put in the text box was being posted using a post method to the web application. Now, these vulnerabilities can exist into GET. And what I mean by GET is when you do a GET, when something is sent as GET, you will see it here in the URL. So if you look at the URL here, you see it's being sent as the username Zaid and password 1, 2, 3, 4, 5, 6. So let me just copy this URL here, and we'll start playing with it from the URL instead of doing it on the web page. I just want to show you a different example, because in many places there might not even be text boxes. For example, it could be something like news and news.php. So we can see here, for example, in this example, it's index.php. And in your pen testing, you might see something like news.php. And for example, ID is equal to 2. And then you can try to inject stuff in there. So we're having an example here where we're going to be injecting things into the username field, which is this field. And we're going to be injecting stuff in here. So anytime when you're doing your pen test, anytime you see parameters like this, you should try to inject them. Anytime you see something.php and then you have a parameter equals something, then always try to inject stuff in there and see if it works for you. So we also seen a way of discovering the injection, and that was using the quotation mark and using the AND. So we do a false AND and a true AND 1 is equal to 1, and then and 1 is equal to 2. And if the server is executing what we want, then we're going to know that there's an SQL injection. I'm going to show you another way of discovering these exploits, and it's using the order by. As the name suggests, the order by statement is used to order the results that we get on the screen based on a specific column. So our injection is going to be like this. So I'm going to do order by 1. So this, if the injection exists, this should work, because in each select statement there should be at least one column is being selected. Therefore, when we say order by 1, we're saying I want to order the results based on the first column. Therefore, this should always be acceptable by the database and return a true or something that we expect. We also need to add the comment in here and execute this code. So it's exactly like before. So when we're doing this, basically, this is our URL. And what's going to happen on the database, so this is the code that's being executed on the database, it's going to look like this. So it's going to be select star from accounts where username is equal to Zaid, and note how this is closing the quote, and we're going to do an order by 1. And there should be this code here for the end. And this comment will tell the SQL interpreter that to ignore anything that comes in after it. So all of this is going to be ignored. So I'm copying this. So you can actually paste this injection for Zaid order by 1 into the name right here, and that's going to work. But again, I just want to show you a different way of doing it by injecting it through the browser. Another thing that I want you to note is when you're injecting stuff into the browser, the code should be encoded. So for example, this sign usually, when you put it on the URL, it should be written as %23. Spaces, for example, get converted to %20, and %23 is the comment that we're using. So I'm going to copy that and replace my comment sign with it. Now you can Google HTTP encoder and you'll see online, there's online tools that will just convert this for you. For me now, I know that the hashtag can be converted to %23, so that's why I'm using it there. And I'm going to hit enter. And as you can see, now we're seeing something that's acceptable. Nothing wrong, and then it's showing me the information about Zaid 1 2 3 4 5 6 and showing me the signature. So it is ignoring the password, so the injection worked, and it's ordering by 1, so it's not showing me anything wrong. Let's try to make this number 1 a very large number. So I'm putting 10,000 or 100,000 now. So what we're saying right now is I want you to order the results that will be returned by the current select statement based on column 100,000. Now, chances are there aren't 100,000 columns used in this select statement, and therefore this should return an error. So when I execute this, you'll see that there is an error. And the error is in the order clause, and it's telling us that there is an unknown column for 100,000. And this is great because now we know that the database is executing what we want. So when we told it to order the results based on the first column, it showed us results. So it followed what we told it. And then when we told it to order the results based on a column that does not exist, it gave us an error. So it's obviously vulnerable to SQL injections. Okay, so now we know our target database is called OWASP10. Let's try and discover the tables that exist in that database. So this is our select statement. It's a union select 1, and we have these things. So I'm going to leave this or change these to null because I only want to select one thing now, and I'm going to set this to null as well. And in number 2, we're going to select table name from. Now we're going to select this from a database called information schema. Now I said this in the first video of SQL that information schema is a default database created by MySQL, and it contains information about all other databases. So what we're doing now, we're selecting the table name from information schema dot, and after the dot you put the table. So basically we're selecting a table called tables from a database called information schema, and the column that we're selecting is called table name. So we're selecting table name from the database that's called information schema from the table tables. Let's execute this and see if we can get all the tables that exist in OWASP 10 database. So we can see we got 237 records, and you can see all the tables that we have. So these are all the tables that we have access to. So again, I said we are logged in as root, therefore we can actually see tables from other web applications such as the TikiWiki, but in real life scenarios, you'll only see tables related to your current database, which is Matilda. So what I'm going to do is I'm going to use a where clause, and I'm gonna say where the table schema is equal to OWASP 10. So OWASP 10 was what we got when we selected the database. So we got OWASP 10, which is our current database that Matilda is working on. So we are using the same statement. We're selecting the table name from information schema tables, where the table schema is OWASP 10. So I'm going to copy that and execute it here. And as you can see now, we have so much less tables, and we only have the ones that we're interested in. So we have the accounts, the blogs, capture data, credit cards, hit log, and the pentest tools. Now, if you remember in the first or the second video in the SQL injection videos, I showed you what's the content of the OWASP table was, and it was these tables of the OWASP database. Okay, so now let's try and determine how many columns are being selected into this page. So how much information are being selected and displayed on this page. So to do that, we're going to use the order by command. So we did order by 1, and that returned something that was acceptable, and order by 100,000 gave us an error. So let's try and do order by 10, and we still get an error. So I'm going to do an order by 5, and that works. So let's try to do an order by 6, and that gives an error. So by doing this, we know that there is 5 columns are being selected from a certain table, and it's the accounts table, and displayed on this page. So let's try and build our own select statement and get it to be executed on the target computer. So let's come here and try to build it there. So at the moment, the statement is select star from accounts where your username is equal to Zaid, and we're doing an order by 1. So let's see if we can fix that and get it to select something that we like. So the normal way to select stuff is using this format. But because we're trying to do multiple selects and we're trying to do it from the URL, we're going to have to use a union first, and then we're going to say select. Then we need to imagine what's happening on this application. So in this web application, we know that there are 5 records being selected. So there are 5 columns that are being selected. So we're doing 1, 2, 3, 4, 5. And we got that from the order by command. So let's run this and see what happens. And I spelled union wrong. And as you can see now, the selection was right. And we got the first selection. So the first selection that this line does has been done. And then it did the union. So it combined that selection with another selection, and it showed us something else. And as you can see here, we're only seeing 2, 3, and 4. And what that means is whatever value you put in number 2 or 3 or 4, whatever you want to select, if you put it in there, it's going to be displayed in this page in this particular location. And you can see that here you have results for 2, so whatever you put in 2 will also be shown in here. So let's try to see our database. So instead of number 2, I'm going to say database. And instead of number 3, I'm going to say username or user. And instead of number 4, I'm going to do version. And this will select the current database, the current user privileges that we have, and the version of the database. So let's see if this gets executed, and then we'll talk about it. Okay, cool. So the username is showing up as OWASP10, and that was number 2. So that is the database that we're looking for. So the database is OWASP10. The current user that we're logged in as is root at localhost. So we're the root user. And in the signature, these stuff actually don't mean anything. We're only concerned about this and what we injected. And we injected the version, and we can see this is the version of MySQL, so it's 5.0.51. So at the moment, we know that our database that we're connected to is OWASP10. Usually, in most real-life scenarios, each database is assigned to a certain user. So usually, you're only able to select stuff, tables, columns, data that is located in this current database. At the moment, we're logged in as root, so this web application has been connected to the database as root. So therefore, we can actually access other databases, but this doesn't really happen in real life scenarios. Usually, each user has their own database. So when they connect a web application to a database, they connect it to one database, and therefore you won't be able to access other databases. So we're going to consider that. We're going to assume that we only have access to OWASP10, which is our current database for this current website, and that the username is root at localhost. In the next videos, we'll see how we can further exploit this and do more powerful select statements. Now let's see if we can select and have a look on all the accounts that exist within this table. So let's see if we can query the database and read the information stored in the accounts table. To do that, we're going to first need to know the column names of the columns that exist within this table. Because if you look at the way we're using our statement, we're doing union select column name from a table. So we still don't know what columns exist in accounts. Now we can try and guess that there is a username and a password, but sometimes they could be different names. So I'm going to show you how you can select the columns for a certain table. The command is going to be very similar to the tables command. And the only difference is instead of table name, we're going to say column name. And instead of selecting it from the information schema.tables, we're going to select it from information schema.columns. And we're going to say where the table name is equal to accounts, because we're interested into the accounts table. If you wanted to get columns for another table, then you just substitute this with the table or with the column with the table that you want. So our command is going to be union select one column name from the information schema.columns, where the table name is the table that we're interested in, which is the accounts. And this should show us all the columns that exist within the accounts table. So let's run this command. And perfect. Same columns that we've seen before, and it's CID, username, password, my signature, and is admin. Now let's take this one step further and select the usernames and passwords from the account table. So again, the command is going to be very similar to what we're running at the moment. We're going to be selecting, and we're going to select username, and I'm going to select the password for number 2, and for number 3 we're going to select the is admin. Now remember, I can't select anything instead of number 1 and number 5 because they're never displayed for me on screen. The only thing that I see was number 2, 3, and 4, which were displayed here, 2, 3, and 4. So therefore, I'm only substituting values for 2, 3, and 4. And we're going to select that from accounts. And we're not going to need the where, so I'm going to delete the where. So very simple statement. We're selecting username, password, is admin from the accounts. And this should return all the usernames and passwords that exist within the current table, that exist in the accounts table. And I have an extra quote here that I'm going to delete. And as you can see, we got all the usernames and passwords. We have the admin, and their password is admin pass. We have other users, and we have their passwords, and it's also telling us whether they are admins or not. This is very useful because in most websites, when you log in as admin, you have so much more privileges than a normal person, and then you'd be able to upload PHP shells or backdoors, viruses, whatever you want to do really, and then further exploit the system. So at the moment, I can actually log in with a username admin and a password admin pass, and it's going to accept that because it's correct. So no matter how complicated the password was, we're just going to be able to read it because we're reading it straight from the database. In this lecture, I'd like to show you how we can use SQL injections to read any file in the server. So even if the file exists outside the www root, we'll be able to read it exactly like a file disclosure vulnerability. And we'll also see how we can use it to write files and upload them to the system, just like a file upload vulnerability. So the first thing we're going to have a look at is the read in the file. And I'm going to set everything to null here. So I have my statement here, and I'm going to set select 1. I'm going to leave number 2 because I'm going to do stuff in that. And we're going to do another 3 nulls here. So null, null, null. So we have select null, something, null, null, null. So 5 because we have 5 records when we did the order by. And instead of selecting something, remember in the third video we did select database, for example, and it showed us the current database. What I want to do now is I want to do another function, and that function is called load file. And in here, I'm going to set the file that I want to load, and I'm going to use the same file that we had a look on in the file inclusion vulnerability, and it was etc password. So we're trying to read that file, and our statement is union select that file, and that's it. So I'm going to copy this, and I'm going to inject it here, and I'm going to add my %23, which is my comment. And as you can see, we managed to read all the information, all the content of etc password, even though it's not in the web root, so it's stored in etc password. So we can read anything in the server from other websites, from other files, anywhere in the server we can read it by specifying the full path of that file. The next thing I'd like to show you is writing to the server. So we're actually going to write stuff to the server. And this is very useful because you'd be able to write any code you want. So for example, you can write the code for a PHP script, you can write a code for a shell, a virus, or a PHP code to get a reverse connection to you. So it'll basically just act like a file upload vulnerability. And to do that, I'm going to write the code that I want to do here, and I'm going to call that, for example, just example. And we're going to use a function called outFile. So we're going to do into outFile, and then we're going to specify where we want to store that file. Now, in best case scenarios, you'd be able to write to your web root, and that will mean that you can access the file through the browser and execute it. So you can upload a Weebly file and then connect to it and do stuff like that. So let's try to do that first. So we're going to do it in var www, and that's our web root, so we'll be able to access things through it. Or you can put it even var www and then put Matilda after it to store it in there. So the command is very simple. Again, union select, make sure you set everything to null so that nothing gets written to the file except what you put in here. And I put example, and it's going to be stored into a file in var www Matilda, and we'll call that example.txt. Let's try to run this and see if it works. Now this didn't work, and if you come down here, you'll see that SQL or MySQL is not allowed to create or write to this directory. So the problem is the permissions that we have don't allow us to write to this particular location. So just to test this exploit, I'm going to change this location to TMP, which is the temp. And you'll see that you can actually write to temp. So in real life scenarios, it depends. You can try it and see if you're able to write stuff or not. In this, we're trying to write to temp now. And if we read in temp, if we clear that, and then ls in temp, you'll see that we have something called example. And if we try to read that, you'll see that it contains the content of what we did before, which was the normal selection that you'd see. So what you see for putting the stuff for admin, and then it showed us what's in there, which is example, which is what we wanted to write to the file. Now you can obviously get rid of the admin and the admin pass stuff by just putting a wrong username, and nothing is going to be displayed here. So the only thing that you'll see is the output, which is example. But again, this is only useful if you're able to write to your web server, so you can access it and then use your shell or use your payload and further exploit the system. As you've seen so far, SQL injections are very dangerous. And also, they're very easy to occur and very easy to find. You'll find them everywhere in some really famous websites. People try to prevent these vulnerabilities using filters. Filters can make it look like there is no exploits, but if you actually try harder by using encoding, different types of encoding, or using a proxy, then you'll be able to bypass most of these filters. Some programmers use a blacklist. So for example, they prevent the use of union, they prevent the use of insert and stuff like that. Again, it's not 100% secure. It can be bypassed. Using a whitelist, exactly the same issues as the blacklist. The best way to do it is to program your web application in a way that it does not allow code to be injected into it and then executed. So the best way to do that is to use parameterized statements where the data and the code is separated. And the best way to show you what I mean by that is using an example. I'm keeping the least amount of programming in this example. I don't want it to be a programming example. There's actually mistakes in the programming in there, but I'm trying to give you the concept more than how to program it. So the vulnerable code that we were looking at used to do this. So it used to do select star from accounts where username is equal to whatever we put in text box 1. And then we used to put in text box 1, let's just put it here. We used to say admin and then close the quote. And then we're able to do a union, select, and execute something else. And then once we're done, we used to add the comment, which basically ignores everything that comes in after it. So when you copy this and you paste it in here, you'll see what's happening. So it's selecting. Now let's just get rid of this, because this is just making the colors not nice. Now I'm actually going to just put a comment on this. So it's going to do a select star from accounts where username is equal to admin, union select, and execute whatever we want to do. This is very bad, and it's very hard to protect against. As I said, using filters and stuff will only hide the problem, will not fix it. The best way to do this is using the parameterized statements, just like so. So this is the safe way to do it. First of all, you prepare your statement. Most languages like PHP and all of them, they actually have a function like that. And you can prepare select star from accounts where username is equal to question mark. And then you send the values. So PHP now knows the SQL statement is select star from accounts where username is equal to something. And then it's going to take the value of text box 1. So even if we come in and we use our very sneaky statement right here and paste it in there, the web application will know that the value for this is admin union select. So it'll actually try to go and select star from accounts where the username, and then it'll add its own quotes and it try to find a username with the following username. So this whole thing will be executed like so. So it'll be select star from accounts where username is equal to admin union select this hashtag. So it'll never, whatever you put in your text box will be sent as a value, and the web application will know that this is a value, it's not a code, and it'll never execute it. Therefore, this will protect you against SQL injections. You can use the filters as second line of defense, and I also advise that you use the least privileges possible. So use for each database, use one user with the least amount of privileges they want. So don't allow the users to do anything that they want. Allow them, if it's a simple website that only does selection, then only allow the user to select. If it only needs to select and insert, then only allow them to select and insert. And this is a rule you should keep with everything, even with Linux systems. Make sure the permissions are always as least as possible. Each user don't have any extra permissions that they don't need. In all of the lectures so far, we were exploiting SQL injections manually. So we were injecting the code into the URL or into the text boxes. In this video, I'm going to show you a tool called SQL Map, which allows you to do everything we learned so far and even more stuff. This tool can be used against MySQL databases, which the one that we were having the example on. It can also be used against Microsoft SQL, Oracle, and other database types. The tool is very useful and is very handy in many cases. Sometimes the injections aren't as nice as the one we see. Sometimes you only get one output for each record and you have to loop through all the outputs. So the tool can automate that and just do everything for you much easier and much simpler. So let's first of all get the URL that we were using for the injection. So I have that text file here that we were using, and I have the URL that we were using before. So it's the userinfo.php, username is admin, password admin pass. You don't really need to know the username and password, so I'm actually just going to put anything here. So just to assume that we don't know the password. So we're only injecting SQL injections. We don't really need to know any of this stuff. All I'm going to do is copy this, and then I'm going to run SQL map, and I'm going to do U to specify the URL, and I'll put my target. And I'm going to make sure that I have it between 2 quotation marks so that it doesn't ignore anything in any signs in the middle. So we have some signs and characters in the middle that I wanted to all be treated as one URL. So all I did is SQL map U my target. And I'm going to hit enter, and the tool will automatically look through all the parameters. So it's going to look through the user info, through the username and the password to see if any of them is injectable. And then once it does that, it's going to store it in its memory. So it's going to know that this is injectable, and then we'll be able to further exploit the target. So as you can see now, it's thinking that our target could be MySQL or PostgreSQL. It's asking me if it should skip other tests, and I'm going to say yes, because I know it's MySQL. And now it's asking me if it should do all the tests for both databases, and I'm going to say yes, assuming that I'm not sure which one it is. I know it's MySQL, but I'm just going to let it do its thing, and we'll see if it can do it properly or not. So at the moment, it's checking if it's PostgreSQL, and I'm assuming it's going to know that it's not, and then it's going to know that it's MySQL. It just found out that the username seems to be injectable. And sure enough, it's telling us here that the parameter username is vulnerable and we can inject it. So it's asking me, do I want to check the other parameters, such as the password and all of them? I can say yes and let it do it, but I'm going to say no, because I don't mind if it just uses the username for the injection, so it's all good. Now SQL map knows that the target is injectable, and it knows that it's going to use the username parameter to inject stuff. And we can see that it figured out that it's running Linux Ubuntu, and it figured out that it's using PHP with Apache 2.2.8, and it's using MySQL server as the database server. So let's run SQL map help and see what we can do now. Now, this tool is really big and it allows you to do a lot of things. So in this video, I'm actually just going to show you a quick look on the video, and I recommend you spend more time with it and try to see what else you can do with it. Okay, so let's try to get the current user, and we're going to try to get the current database. So we're going to use the same command that we used before, and I'm just going to add to it dbms to get the current databases, or DBs, sorry. As you can see, we got all the database that we have. So we have DVWA, we have information schema, Metasploit, MySQL, OWASP10, which was the one that we were exploiting before, and TikiWiki. Now, if we do current user, you can see that we are root. And if I do current database, we'll see that OWASP10 is our current database. So now let's try to get the tables for OWASP10. So remember when we did a select table name from information schema.tables, where table name, where table schema is equal to OWASP10. We're going to let SQL map do all of that for us. And so the command is going to be, we're going to ask it to get all the tables for us. And we're going to use the D option to specify the database. And our database is going to be called OWASP10. And as you can see, it got us all the tables that exist. And remember, it's the same. We got accounts, blogs table, and the credit card as well. And now if we want to get the columns, then we can use the same command again. And we're going to say, get me the columns, where the table is called accounts and the database is OWASP10. And right here we can see that we got the columns. So we have the isadmin, the password, and the username. And we can get the data using the dump option. So it's the same command that we used before. So we're getting from the table that's called accounts and the database that is called OWASP10, I want you to get me all the data. And here we go. We got all the data. We have the admin, its password admin pass, and we have Adrian and his password is some password, and we got all the data right here. So as I said, the tool is very useful. It can be used to make our life much easier, and it does everything automatically, and it can do everything we did, and it can even do more stuff. So let's talk about how to discover these kind of vulnerabilities. Very similar to SQL injections, the way to do this is you browse through your target and try to inject any text box or any URL that looks similar to this. So whenever you see a URL with parameters, try to inject these parameters or try to inject into text boxes. So let's have a look on a reflected XSS example. So these are the non-persistent, non-stored vulnerabilities where you have to actually send the code to the target, and once the target runs the code, it will be executed on their machine. So let's have a look on our DVWA website, and I'm just going to log in. And then we're going to have an example of a reflected XSS. So as you can see now, you can put your name here for this text box, and it's just going to say hello. Now this is obviously just an example, but the idea is you can inject into text boxes. Also, if you have a look at the URL here, you'll see that it's a get, so you can inject into the URL as well. So let me start a leaf pad. And let's try to inject XSS code on this and see if the code will be executed, or JavaScript code, sorry. So what I'm going to use is a very simple script. So we're using the script and a /script tag. Now there is a lot of ways into discovering these kind of vulnerabilities and a lot of ways to bypass filters, but for now we're just having a look at the basic case where we can inject a normal script. And I'm going to say alert, which is just a function to give an alert, to give a text box. And I'm going to say XSS. So I'm going to click on submit, and we'll see if this code will be executed. And as you can see now, it's actually executing my code. So instead of saying hello Zaid here, it said hello, and my code has been executed and it produced this XSS. So we can do the same here. If you have a look on the URL, it actually already did it for us. But if we look at the URL here, it's just going to be a bit bigger there. We can see that the name has been now, obviously all of these characters are just HTML escape characters. And now if you send this URL to anybody, whoever views that URL, the code will be executed on their machine, and it's going to say XSS. So let me show you here. You can also inject this in the URL. I just want to show you the whole idea of that. So we have script /script XSS. And if I hit enter, the code will be executed. So as I said, we can copy this and send it to a certain person. And once they run that code, this code will be executed on their machine. In this lecture and the next few lectures, we're going to talk about a vulnerability called XSS. XSS is short for cross-site scripting. This type of vulnerability allows an attacker to inject JavaScript into a page. So JavaScript is a programming language, and using this vulnerability, an attacker would be able to execute code written in JavaScript into a certain page, into a website. JavaScript is a client-side language, So when the code is executed, it will be executed on the client, on the user, on the person who is browsing the web page. It's not going to be executed on the server. So even if your code results into giving you a reverse shell, the shell will be coming from the user who is browsing the page, and it's not going to be coming from the website. So any code you write in JavaScript will be exploited or will run on the target user, on the people who see the pages, and it's not on the web server. So the web server is only going to be used as means of executing the code or delivering the code. There's three main types of XSS vulnerabilities: persistent or stored, reflected, and DOM-based. The stored XSS gets stored into the database. So the code that you inject will be stored into the database or into the page, so that every time any person views that page, your code will be executed. And the reflected one, the code will only be executed when the target user runs a specific URL crafted or written by you. So you'll be manipulating some sort of URL and send it to a target. And when they run that target, when they run that URL, the code will be executed. The DOM-based results from JavaScript code written on the client. So the code will actually be interpreted and run on the client side without having any communication with the web server. These could be very dangerous because sometimes web servers apply some sort of security and filtration to check for XSS, but with DOM-based, the code never gets sent to the web server. So the code will be interpreted and run on the web browser without even interacting with the web server. And these will be present into websites that update their content without refresh. So we've all used websites where you put your username, for example, and it loads in straight away without having to check with the web server, or you put some sort of a string and it does a search without communicating with the web server, or it does something without communicating with the web server. So if you're able to inject into that, then this injection will not be validated, so it'll be executed straight away and bypass all validations. Okay, now let's have a look on a stored XSS example. Now, stored XSS is very similar to a reflected one. It allows you to inject JavaScript code into the browser. The code is executed on the people that visit the page. The only difference is with the reflected, you had to send the URL to your target. So the target had to actually click on a URL for the exploit to run or for the code to run. In the stored XSS, the code will actually be stored into the database or into the page. So every time any person runs that page, they will see your code and your code will be executed. So you won't need to interact with any users or send them anything. Therefore, this could be much more dangerous than reflected XSS. So let's have a look on this. Now, I clicked on the XSS stored here on the left, and you have this page. And this page just allows you to add a message to the system. So I'm going to put my name as Zaid. We're just going to do a normal test first. And we're going to put a message body, for example. And then I'm going to sign the guest book. And you can see that Zaid added a message called message body. So if we go to here into another machine, so this is a different machine into a different place. And if we go on the XSS stored, we can see that there's two entries. So the entries are being loaded from the database and that they contain the entries in that database. So if we manage to inject code in here, then any person who runs this page, the code will run on it without even having to send that person anything. So let's try to inject stuff here. So let's put my name as Zaid. And I'm going to try to put my code in here. So I'm going to try to inject into the message. And I'm going to put it as script. I'm going to use the exact same test code that we used in the previous video. Just a message saying XSS. Again, very basic code. But it serves for the purposes of this video. And we're going to say alert XSS. And I'm going to try to sign the guest book. And as we can see now, I got the XSS here. But the real magic happens when a normal person, so let's just go home first, and let's assume this is just a normal website and people just are coming and browsing it. And once they're going to go to the guest book, JavaScript code will be executed on their system from that website. So the code is coming from that website and is going to be executed on every person that visits this page. Again, we're just showing a proof of concept here. In future videos, we'll show how to further exploit this kind of vulnerability. Now let's talk about how we can prevent XSS vulnerabilities. The way these vulnerabilities happen is because whenever a user enters something into a text box or into a parameter, that input is displayed into the HTML. So it's treated as if it's part of the page, and therefore, if there is JavaScript in it, the code is being executed. So to prevent this exploit, the best thing to do is to try and minimize the usage of untrusted input. So anytime a user inputs something or anytime something's input from parameters, try to minimize that. Also, make sure that you always escape whatever that's going to be displayed or used into the HTML page. Because XSS can not only be injected into places where things are displayed on the page, but it can also be injected into parameters of certain elements of the HTML page. So what I mean by escaping is converting each of these characters to what they would be represented by in HTML. You can do that using scripts, and you can do that using your own script. Now let me show you how this happens. Now I'm here at my vulnerable web page that we were using, and I'm going to go to the stored one. And obviously you can see that every time we click on that, the XSS runs. So let's inspect this element. Now this element is where we injected our alert. And if we right click and go on inspect element, it will show us the HTML of this page, or the HTML of this particular element right here highlighted. So I'm going to make this bigger. And if we look at it right here, you'll see that we have the name, and that's Zaid. And then the other input, which is the message, it's a script. And the script, what the script does, it does alert XSS. So it's exactly what we injected into it when we did the comment. So every time we run this page, this piece of code is executed. So what we need to do is we need to make sure every time a user enters something, and that something will be displayed on a page, or that something will be used somewhere in the element. So even the ID here, or even the ID is just, for example, is a parameter of the div. It's not displayed. You never see this ID, but this can be injected as well. So hackers can actually try to inject stuff into the parameters. They can try to inject stuff into the image attributes, for example. They can do an image and inject stuff into the source or into the URL. So this is just an example here. And every time a user's input is going to be used anywhere on the page. So even if you don't see it, if you usually don't see it, you need to make sure that you escape that input and make sure that it does not contain any code. And if it contains any code, then it's converted to an equivalent that the code will not be running. So it's converted to its HTTP equivalent, so that you'll actually, once you escape this, you'll actually see this in the message. So you see the message as script alert XSS, but it will never be executed. This script will never actually be executed on the target person when they run it. Now, as a user, to prevent yourself from being used into an XSS attack, now the URL coming to you will probably look like a URL of a trusted website. For example, let's assume that you work in a company and there was an XSS in your company and you were logging into your company and the code gets executed on you, then there isn't much you can do yourself. But you need to be careful. So with Beef, we saw in order to exploit the vulnerabilities, we were showing, for example, a fake update. So make sure if you get a message always that there is an update, make sure you actually go to the website that provides that application. So if Firefox said that there's an update,